All right, so for this problem, we're given a spherical balloon that is increasing with its volume at a rate of 4 feet cubed per second. What we need to find is the rate at which the radius is increasing as the volume of the balloon is increasing at t equals 2 minutes. So we can modify that to dr over dt at t equals 120 seconds because the units need to be in seconds, and it also needs to match the volumes units in seconds. So we can go ahead and start out with the volume of a sphere equation, which is v is equal to 4/3 pi r cubed, and parametrize it in terms of t. So v becomes v of t and r becomes r of t. And then v of t will equal 4t. And r of t will be the initial, will be the radius in terms of time. So what we can go ahead and do is we can say, okay, well, 4t is equal to 4/3 pi r of t cubed. And then we can go ahead and rearrange this to get this in terms of r and t. So the 4's are going to go away, and then this just becomes 3t over pi cube root is equal to r of t. All right, so we can go ahead and say that dr over dt is going to be equal to 3 over pi to the 1/3 times 1/3 t to the negative 2/3. And this t to the negative 2/3, what this means is that as it's expanding and time is increasing, the rate of expansion is going to get slower and slower as it's getting to that point where it's about to burst, right? So it makes sense that it's a negative exponential. So we're on track here. Now what we can do is we can go ahead and say, okay, well, if we take dr of dt at t is equal to 120, then we can go ahead and just plug 120 into here. So it'll be 3 over pi to the 1/3 times 1/3 times 120 to the negative 2/3. And this should come out to approximately 0.0134 feet per second. And does that make sense? Yes, after 2 minutes of being inflated, it should be increasing at a slower and slower rate. So it makes sense that we get a very slow rate. And that should answer your question.